All right, let's jump right in. We're about to unpack a modern-day fable. But instead of a quiet forest path, our racetrack is the cloud. And this is a story all about data security, where we're going to pit the promises of the past against the cold, hard laws of physics.
So, let's meet our contestants, shall we? On one side, you've got the hare. He represents the traditional legacy cloud. He's fast, he's flashy, and he's built on a foundation of promises. And on the other side, the tortoise. He's armored, methodical, and he represents a totally new way of thinking called VaporAudit, which uses physics itself to guarantee security. And what are they racing for? Well, nothing less than the absolute, verifiable security of your most important data.
Now, to really understand this race, we first have to look at the hare's strategy. So let's pull back the curtain and really break down the fundamental problems with the legacy cloud system he's repping. And this slide just nails the core problem. See the hare on the right? He's standing on these train tracks holding up this tiny, flimsy shield of software policies. And what's coming at him? A massive train labeled hypervisor. Now, the hypervisor is the software that runs all the virtual machines. It's the very foundation of the cloud. That train represents a hostile memory environment, which is a fancy way of saying the infrastructure you're renting can actually turn on you. And the hare's little policy shield? Yeah, it stands no chance against an attack coming from that deep. So it all comes down to the foundation they're each built on. The hare, well, he's standing on the quicksand of logical trust. What does that mean? It means he's trusting things that can be faked, like software-defined region IDs or just an administrator's promise. The tortoise, on the other hand, builds his house on the bedrock of immutable physical constants, like the speed of light, things that, simply cannot lie. Let's get a little more specific here. The first big problem is something called Ring 1 blindness. Think about it like this. Your security software is running up here, inside your virtual machine, but an attack can come from the level below it, the hypervisor itself. Your software is completely blind to it. Then you've got teleportation attacks, where someone can literally move your entire workload to another country, and the logs you see, they'll still say everything is perfectly fine. It all boils down to this outdated honor system that just doesn't work anymore. Okay, so the hare's strategy is clearly flawed. Let's switch gears and talk about the tortoise. Let's see how you build a defense that doesn't have to rely on trust at all. This quote right here, this is everything. It is the absolute core idea behind the tortoise's entire strategy. You see, policies can be bent, they can be broken, they can be totally ignored. But the laws of physics, they're absolute. And that is what VaporAudit uses as its ultimate enforcement mechanism. The tortoise's iron shell, his impenetrable defense, is really made of three core principles, or as they call them, mandates. First, you have Alibi routing, which uses the speed of light. Second, the microcode Sentry, which taps into thermodynamics. And third, the sovereign handshake, which uses some seriously advanced cryptography. You put those three together and what you get is physical, verifiable data sovereignty. Okay, now this is where it gets really, really cool. Let's look at how Mandate 7 works. The system is constantly timing how long it takes for a signal to bounce off trusted locations. Now, we know the speed of light through fiber optic cable is a constant. It's roughly 200 kilometers per millisecond. So if a signal suddenly takes longer than it's supposed to, say more than 15 milliseconds, that's not a suggestion. It's mathematical proof that your data has been moved outside its authorized zone. Game over. And then you've got Mandate 8, which is, and I'm not kidding, basically a thermodynamic lie detector for your CPU. A silent observer attack doesn't leave a trail in the logs, but it does use CPU cycles. This creates what they call an energy shadow, a tiny little change in the heat and timing of the processor. The microcode Sentry is so sensitive it can detect that variance, proving that someone is watching, even if they leave no digital footprints behind. All right, so we've got the hare's policies versus the tortoise's physics. Now it's time for the climax of our story. Let's throw them both into the ring against a direct attack and see who actually wins this race. So here we go. The attack is on. You see this ninja? He represents a silent observer operating at that deep hypervisor level, and he's snooping on the system. Now look at the hare, our legacy cloud security guard. He's just staring at his monitor, which reads logs equals clean. He's completely, utterly oblivious because the attack is happening in his blind spot, totally beneath the visibility of his tools. Okay, now the attacker goes in for the kill. He tries to take a snapshot of the memory to steal all the data. The hare, he's caught totally flat-footed. His cleanup process is way too slow. But the tortoise, He doesn't even bother trying to clean up. The very instant that Thermodynamic Sentry detects the breach, it hits the big red button and initiates something called cryptographic suicide. So what in the world is cryptographic suicide? Well, it's a fail-dead protocol, which is very different from a fail-safe one. The system doesn't try to recover or protect itself. Nope. It physically overwrites all the sensitive memory with random digital noise, a process they call 0xF Scorch. It basically scrambles the data into meaningless gibberish at the hardware level. The principle is as simple as it is brutal. It's better for the data to be dead than read. In other words, destroyed, rather than captured by the enemy.
And there you have it. Our winner, the tortoise, crosses the sovereignty finish line. But here's the real lesson. He didn't win because he was faster than the attacker. He won because he completely changed the rules of the race. He just refused to play the hare's rigged game of promises and policies, and instead, he enforced his own game, one based on the unbreakable laws of physics.
You know, this fable isn't just a clever story. It has some pretty profound real-world implications. So let's talk about the moral of the story and what this all really means for the future of security. And this slide really brings it all home. You've got the confused hare finally getting the lesson from the tortoise. The old honor system, the one that relies on blindly trusting your provider, it's dead. What this means is that you no longer have to just trust that your data is safe and where it's supposed to be. You can now mathematically prove it. And this isn't just a concept, it's a real technology stack that exists today. The foundation is hardened hardware, like Google Distributed Cloud. The weapon of choice is the Rust programming language, which is famous for its intense focus on memory safety, stopping a whole class of hacks before they can even start. And the enforcement layer? That's the system we've been talking about, VaporAudit, with its 8 interlocking physics-based patents. So the final verdict is in. We're really talking about a fundamental shift in thinking here, moving away from trusting the changeable policies of men and instead verifying the unchangeable laws of nature. The hare relied on coordinates that could be faked. The tortoise anchors your data to a specific piece of silicon and its undeniable physical place on the planet. And that really leaves all of us with one last really crucial question to think about. When everything is truly on the line, your company's secrets, your customers' data, your country's security, are you going to bet on a simple promise from the hare, or are you going to bet on the absolute certainty of physics with the tortoise? The choice really is yours.